check the quality of nested models. Okay, so what do you mean by nested model first of all? So nested model means where we have both, unrestricted model first of all. Let's say unrestricted model is y is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3. This is unrestricted or full model. Okay, unrestricted or full model. Then we have restricted model. Restricted means what? I'm taking only, part of it. So part of it as in, say for example, y is equal to b0 plus b1 x1. So only this much I'm taking. Okay, instead of, so I'm avoiding like second and third independent variable over here. So this becomes my restricted variable, restricted model. This will become my restricted model. Okay, so in this case, how do I check the quality of this model, whether it makes sense to use this restricted model or I'm supposed to go for unrestricted model? That's what this topic is all about. So which model should I go for? If this restricted model is good enough, then I don't have to go for unrestricted model, right? So that's what I'm going to check now. So I want to see if, this one which we are not taking it in the restricted model, is this significantly different or not? This B2 and B3 is significantly different or not? That's what I need to check over here. Okay, so my null hypothesis will be that B2 and B3, okay, they are equal to 0 or not significantly different or equal to 0. Alternative is B2 or B3, either of this, even at least one, is not equal to 0. That means at least one is significantly different. Okay, so this is the decision rule. This is the decision rule. So now the formula to check this nested model is, F test. In level 1 we have done like this, bigger variance by smaller variance, right? Now in level 2, the formula is similar kind. So here it is SSE, sum of the squared error of the restricted one, minus, so what is sum of the squared error? That is there in the ANOVA table video. Okay, so sum of the squared error, so I'm assuming you know this one now, SSE, sum of the squared error of the restricted model, so R stands for restricted model, minus sum of the squared error for unrestricted model. Okay, divided by Q. So Q represents the number of variables excluded. So over here excluded is 2. Okay, so this is similar to variance, kind of thing, you can think like that, divided by another variance. So another variance is total unrestricted one in this part. So unrestricted is sum of the squared error of unrestricted divided by n minus k minus 1. N is number of observations and k is number of independent variable. So this is the degree of freedom. So using this, whatever output I get over here, okay, I am supposed to check with the critical value of the F test table. Okay, and when I check with the critical value of the F test table, so if F test statistics is greater than the critical value, so critical value means how will I get this critical value? I will get it from the F test table. Critical value of the F test table. So if this is the case, I will consider, so I will reject the null hypothesis. I will reject the null hypothesis. That means I will accept that at least B2 or B3 is significantly different, that means restricted model is not the best one. So that is the output. So this is how we can check the quality of the restricted model. Okay. Now to extend this concept further, suppose now let's say by the way, if I have to check individually if all this all these slopes are significantly different or not, then I'm supposed to go for t-test. But here I'm checking the entire model. Okay, so that's why the model will tell you that at least one is significantly different. If I can extend this concept further, see, y is equal to, if I take another example, y is equal to, let's say, you know b0 plus b1 x1. This is the full model, assume full model or unrestricted model. And the restricted model is, let's say, only y is equal to b0. Now b0, so here see, error is always there, right? So error is silent, but it is always there. Now let's say y is equal to b0 plus 10. So this 10 is the error. Now when I add another variable, x1 y1 x1, I mean b1 x1, when I add, let's say this is the regression line. So when I add this x variable, okay, and try to predict y, total it was 10 error before. Now when I add x variable, I'm able to predict, this is y hat, y bar and y. Let's say I'm able to predict 7, and this is still unpredictable for me. This is still an error. So I can categorize this as 7 and 3. This is just a random number I'm giving to explain it to you. So I can rewrite this as, this is b1 x1 plus error. So that means in the restricted model, this is my sum of the squared error of the restricted one is 10. That is equal to, this is explained, 7 is explained, 3 is unexplained. So that is equal to SST, sum of the squared total, because it includes explained as well as unexplained. So that 10 is categorized as 7 and 3. So I can say this 10 is equal to 7 explained and 3 unexplained. That means sum of the squared error of 10 is equal to sum of the squared total. That's the point I'm trying to prove over here. So sum of the squared total is this much over here. This 7 is explained and 3 is unexplained, whereas 10 is completely an error in the restricted model, and in the unrestricted model 7 is explained, 3 is unexplained. So SST becomes equal to, so SST of the unrestricted model becomes equal to sum of the squared error of the restricted model. So for this reason, now I can further extend this formula. See, f test, let me rewrite this as it is. So here f test is equal to SSER minus SSEU by number of left out variables, q is left out variables, divided by, so divided by SSE unrestricted divided by n minus k minus 1 degree of freedom. Now I can say this SSE of the restricted one, okay, is equal to, okay, is equal to SST of the unrestricted one. So SST of the unrestricted minus, I'm just taking everything from the left hand side here. Okay, and here in this case, see, number of left out variable is equal to k, because I have not taken any variable. So the intention over here is to find out even if one of the left out independent variable is significantly different or not. Okay, so in this case I have left all the independent variable, so that's why all the independent variable is equal to all the left out variable. That means q is equal to k in this case. Okay, divided by SSE divided by n minus k minus 1. Now this SST minus SSE of the unrestricted model, I can rewrite this as SSR, sum of the squared regression. Okay, now in the textbook they have given us RSS, you can take anyways. Okay, so sum of the squared regression or RSS divided by, okay, this is or, so divided by k whole upon SSE u divided by n minus k minus 1. Okay, now if this output, okay, this output again, if this output is, that means f test statistics is greater than f test statistics value, so f test statistics value is greater than the critical value of the f test table, the conclusion is that at least um, one of the independent variable, at least one, see in this case, to explain, to make it easy, I took only one independent variable. Practically you may take like 2 3. So in that case, restricted will be no independent variable, unrestricted will be all independent variable. So here at least one of the independent variable, in this case there is only one, but otherwise let's say there are multiple independent variables. So in that case, at least one of the independent variable is significantly different. That means at least one of the independent variable is significantly adding value, and so we should not ignore it. So this is about how to test a nested model using F-test. Thank you.